Okay, I think we're live. Hello there. Welcome to JAG Champions Conf, the second day. And I'm Keto. I'm your moderator. I'll just be popping, hanging out around to help Brian facilitate his process. But thanks for joining the session. And Brian, take it away.
Thanks, Keto. Great. Yeah, honored to be here. Honored to be a Java champion. And today I am going to be talking about deploying Java apps to Kubernetes with GitHub Actions and feature flags. I'm doing something a little different than I usually do. I'm going to build. I've been told we have a full hour, more if we need it. So I'm actually going to build everything from scratch. Usually, I have a few things sort of pre-baked, but here I'm actually going to build everything. So you're going to see me fumble through building a whole thing from scratch, just like someone would when they're working on a live site. So I guess we get started with that. There is more information you can find at devopsforjavashops.com. These are the only two slides I'm going to show in this whole presentation. So let's get into the actual code. So hopefully you can see my screen here. What we're going to do is we're actually going to start. Let me start with the Azure Portal, and I'll actually show you the application as it's running. Let's see here. Bear with me a moment. There we are. So this is the application I set up last night. And basically, it's just a Spring Boot application. You can find it on GitHub here. And it is a couple of things you want to know. It's built on GitHub. It deploys from GitHub, but also you can deploy it manually, which is what we're going to do today. So I've built it locally, and I'm going to create a container registry, and then I'm going to build a container service, and then we're actually going to deploy the application out to the service and run it from there. It's enabled with something called feature flags, which allows you to, I heard a little bing there. I should say as well, anyone who wants to jump in and ask questions, please do. I'm going to keep this casual, and I can answer questions as we go along. There's going to be a couple of times when things are deploying and building where I'm going to have time to answer questions. So that would be great. All right. So the first thing I want to do, just show you the GitHub features. So feature flags are a way to actually deploy a feature in your application without deploying code. So you can put the code in your application and enable it via a flag. So if I go into my feature manager here, I've got several.
Hey, Brian.
Yeah.
Are you sharing? We don't see your screen.
Oh, I thought it was. Pardon me. Oh, somehow I'm not. Okay. Yeah, that would help. Okay, let me know. Yeah.
There we go.
Yes, thank you. Yeah, something happened there. Okay, apologies. So, I'll start from the beginning again. So, let me see. Let me just show you this. So, the presentation. My name is Brian Benz, Cloud Advocate at Microsoft. B Benz on Twitter. And on Mastodon, and deploying Java apps to Kubernetes. There's a link here, devopsforjavashops.com, where you can find more info, and I'll share this link at the end of the presentation as well. All right. Now, what I was going to do is actually show you the application. So this is the Azure Portal. The Azure Portal is a place where you organize all of the things you need for an application. You go to portal.azure.com. If you have a subscription, you're probably already familiar with this. If not, you can get a free trial when you go to portal.azure.com. And I've got everything organized by presentation because that's how I work. There's different dashboards for each one. And what I've got here is a test that I just ran yesterday to make sure this all works for you good folks, so we're not wasting your time. And a couple other things as well. Some links and things. So this is what they call a resource group, and this is where we're actually going to be creating our Kubernetes cluster today. Now, I was talking about feature flags. So the application itself, here's a demo application. It's a Spring Boot application. It runs, it uses something called feature flags, which is a way to put a feature into an application without actually deploying a separate application for each new feature. You can hide the code in the application you have and turn it on and off with feature flags. And this is what that looks like. So inside of my dashboard, I've got this thing called DevOps for GitHub Features. In Azure, we call it App Configuration. And it's a service, and I can turn on and off these features here. And when I turn on and off these features, it actually enables different things in the application. I can turn them on and off manually. I can schedule things to be turned off. I can set a time window. I can do things like enable 50% of the people to see this feature and 50% not to see the feature. So you can do something called A/B testing, which is where you're tracking who gets to see what. And you see what the new feature has in terms of an effect on user behavior and on the site and everything else. Without actually taking any risks, you can turn it on and off as you need to. And you can slowly adjust that 50% to 60, 70, 80, 90, and deploy it out. That's something else called blue-green deployments that are done there. So what I'm going to do, as I mentioned before, I'm going to build everything from scratch today. And let's get started there. So that's the end result application and the feature flag manager. But let's dig into how we're actually going to build this right now. So we're going to do that. I've got some notes here. And we're going to go through the application itself and how everything works and how everything is deployed. The reason why I like to show this demo with the feature flags is because in the real world, you're always going to have some kind of connection to something. I mean, a Hello World app is easy enough to deploy, but how do you actually make a connection to something? Normally a database, or in this case, a feature flag, includes some other feature inside your application when you deploy it, but you do that securely. So I have a connection string, which is used. Let's go there for a second. If I go into the GitHub features here and I go into access keys, you can't see them, but these are the keys that I need to use to connect my feature flag to the application, and the application won't run without those features. So I need to add this to the application, but I need to do it securely. All right. So I don't want to share that on GitHub. I don't want to share it in open text in my application and things like that. And there are ways to do it securely in Kubernetes and in GitHub Actions. And I'm going to show you how to do that today. So that's important to note. All right. So first thing we want to do, talk a little bit about the application itself. Actually, the first thing I'm going to do here, just a moment, here we go. I'm actually going to go ahead and create a container registry. That's the first thing we need to do. And while I'm creating the container registry, I'm going to tell you about how Docker works with this. So I'm going to go into Azure Portal, create a resource. And in this case, we're going to go to containers. And we're going to go to container registry, create. And I think this one, I'm going to use the same resource group that I have, which is Spring Boot to Kubernetes. And let me just make sure I've got the name right. I pre-built this set of scripts here, so I've got to make sure that everything matches. Just a moment. JChampions Conf. That's the name we want to name all of our resources today. So registry name is going to be JChampions Conf, and I'm going to put it in WestUS 3. We've been having some capacity issues with WestUS 2. And availability zones is just a way to create a backup in different locations for you. It's good for speed, and it's also good for redundancy. The SKU we're going to do today is standard. There's a free tier as well, but I've already used my free tier, so you're only allowed one. So anyway, I have to set it up like that. Networking, encryption. Actually, I don't need to worry about any of this. I just review and create. All right. So while that's creating the registry, let me tell you a little bit about the Docker file that we have here. So I built this application, I've containerized it, and we've got a Docker file here. It uses the Maven OpenJDK Slim as the builder. There's a multi-stage Docker file. It builds the application from the current location of my local machine, or in this case, there's something called a runner, which we're going to run this on, and I'll explain that in a bit. And then it actually runs Maven and does Maven clean install. There is a way to pass that connection string. So I mentioned that we need to use a secure connection string all the time. And that's by using Maven clean install the app configuration connection string, those connection string. So basically, I've created a local connection string. I've already built that securely on my local machine. No one can get to it. But you can pass it to your Docker build using this command. And then you just do a regular Docker build, and it will actually run for you. Next thing we do in the multi-stage Docker file is we have to have the runtime. So for that, we're using the distroless Java 11 Debian distro, and we're going to copy the jar file that gets built as part of the build tasks. And we have an entry point, a server 80, a server port 80, and Java jar, and the snapshot that's actually generated by this by default by Maven. That's basically the Docker file. So let me show you something really cool about that. This should be, yeah, good. So the resource we've got is created. Good. There's one thing we need to do here when I do this. I need to turn on the admin user, because admin user allows third parties to access this securely. You still get a password. You can't see the whole password there, so I can show it, although those should be blanked out. Anyway, so that's the registry. And if I go in here, you can see down here, repositories. Right now, there's nothing in it. Okay, so what we're going to do is we're actually going to build that Docker file that I showed, or we're going to build the application using the Docker file that I showed you. And we're going to deploy that out to this registry. And we're going to do that all with one command, which is kind of cool. So there's one more thing I need to do before I do that. Presentation live notes. I need to where are my notes here? Here we go. I'm going too far ahead. Okay. I need to log in. So I just do AZACR login. This is, by the way, Visual Studio Code. And what I've got here is I've got my, there we go, login succeeded. I've got a script up here that I'm using, and down here there's a terminal, which is just basically command window. You've also got options to use bash and other things, but I'm just using Windows command window today to make all this work. So anyway, we've logged in. That's good. You have to log in, otherwise when you do the next command, it won't work. The next command's pretty cool. So instead of doing a Docker build and a push and all those steps that you need, I can simply do a AZACR build, which is the Azure CLI. So the Azure CLI is something you can download. It runs on Windows, Mac, and Linux. It's written in Python, and it basically allows programmatic access to Azure resources. In this case, what we're doing is we're accessing our container registry that we just created called JChampionsConf. We're going to create an image on JChampionsConf called test feature flags v1. And it's going to do a Docker build, and then it uses something called a hosted runner to actually run this on, or a hosted agent in this case, to run this on Azure. So I'm not actually going to use my local machine for this. So let's see what that looks like. All right. So what it's doing is it's actually looking at the code that I have locally here. It's seeing if it can use it. It's making sure it can. It's going to push it up to the repo. And when it pushes up to the repo, it's going to start this thing called a hosted agent. So hosted agents are virtual machines. Basically, it's a container in a virtual machine that runs on Azure. So it's not taking any resources from your local machine. And it's actually just going to run from there. Let me show you this. So while that's running, let's go back to our dashboard and I can show you hosted agents. So hosted agents are pretty cool because these are the images you have for the hosted agent. In this case, we're going to use, I believe it's using Ubuntu. And if I go into the hosted agent itself, as you can see here, we have Windows, Ubuntu, Mac OS X. If I go into the hosted agent details, you can see in GitHub everything that's loaded, preloaded on these, including Maven and Java and everything I need to actually basically run and test this container before it goes in the registry. So that's kind of cool. Let's go back to our portal and see if it did it. Yeah, okay, so it's successful. It took 1 minute and 13 seconds to deploy. So let's go back to our registry now. Nice one smooth motion. That's what I like about this. So let's go back to our container registry. And if we go into the container registry now, we looked at repositories before. There it is. Test feature flags is there. Yay. So test feature flags is ready to roll. And you can look at V1. V1's there. Everything's ready. So whenever you're deploying to Kubernetes or any container-based application, you need to have a registry. In this case, we're using Azure Container Registry. Docker Hub works, other things work, but it's just easier for me to do this because I could use the AZ ACR build and a few other tools to make that happen. All right, so the next thing we want to do is we actually want to create the Azure Kubernetes service for this. Oh, by the way, I could have done this using a command as well. In this case, I'm using the portal to do all this because it allows me to just show you everything graphically, how you set it up. So we're actually going to create a Azure Kubernetes service now. And that Kubernetes service is going to be linked to our container registry. The Kubernetes service itself, it's a little easier to use than loading. You can, of course, set up a VM on Azure, run your own Kubernetes, whatever you need to do, but it's actually handy to use AKS because AKS manages the control plane for you. So it allows you to handle things like versioning and management of Kubernetes built in. And I'll show you some of the advantages to doing it, including HTTP access. So you don't have to set up your own proxy and all that. It's literally just a click to set up a Nginx reverse proxy to go into your Kubernetes. So let's talk about how we do that. We're going to go into the dashboard again. We're going to go create a resource. And we're going to go to containers again and Kubernetes service. And we're going to call this one JChampionsConf as well. And we're going to use the same resource group. So Spring Boot to Kubernetes. So the preset configuration is standard. JChampionsConf is the name we need to put in there. I'm going to use West US 3 again. By the way, there's tons of different regions we could use. But in terms of latency and ease and availability of resources, I'm using West US 3 these days. It's funny, when you work at Microsoft, we don't always get priority in which resources you get to use. As a customer, you can pretty much pick your regions. But for us, we quite often get messages that tell us that we can't use this particular resource in this region because the customers are using it. So we get a second choice. But West US 3 is usually pretty open. So let's see how this goes. Sometimes I get told that it's not there, but it should be okay. Let's see, high availability. So I'm going to do it automatically defaults to availability zones. And this is just a demo I'm going to delete soon. So I just leave it that way. Availability zones just allows you to Spread nodes, as it says here, across physical locations. And it's just some disaster recovery, backup, redundancy, which is kind of nice. I'm using the standard tier again. You can do upgrades, and there's a couple of things that I need to set up. Node size can be fine. Scale method, it does auto scaling, so the node count range can be 1 to 5. All right, and the node pools, that's fine. I'll just use the default for that. Access control, that's fine. I use the local accounts. Now, networking is where I actually have to set up a couple of things. So we want to do the standard routing. We're going to have the standard load balancer for those nodes that get created and scaled. But the HTTP application routing, this actually sets up an Nginx DNS zone for you, which is important because we're going to need that for ingress control because it's a web application. You need to make sure you do that. You can lock down security. For now, I'm not going to set up any security for this particular application because it's a demo. But obviously, if you wanted to, you can set up a private cluster. You can authorize IP ranges, and there is a way to set up Calico for this as well. So integrations. We are going to use the container registry that we just created called JChampionsConf. And what that's automatically going to do, if we set up container monitoring, it's anytime there's a new container module that goes into that registry, it's going to automatically deploy that out to your Kubernetes cluster, which is not always the best approach, but for now, because once again, it's a demo, it's just a nice, quick, easy way to do this. All right, I think that's it. We don't need to do anything in advanced. Next, tags, review and create. Let's make sure Brian didn't screw up and make this all right. I know I didn't screw up. I've done this a couple times. Okay, validation passed. So it's going to create this. Now, this is variable time. I have a backup if we need it, but hopefully this doesn't take too long. It's first thing in the morning, and we still have 37 minutes anyway. So I don't think it's going to take 37 minutes, but this does take a while to set up because, as you saw, it's going to set up availability zones and all kinds of things and set up our ingress, cool stuff like that. So it's actually going to run. It's going to take a while. So in the meantime, I wanted to show you something really cool. For those of you who may have used Copilot in the past, so everyone's talking about AI and ChatGPT. I actually had a problem yesterday. All of a sudden, if you notice here, I've got a commented out image for my Docker file. So this is the Docker file we're looking at again. And the Docker file itself just wasn't working. Maven just wouldn't run in this Docker file. And I couldn't figure out what was wrong. I was searching on the web. I was trying to figure out, why doesn't this work? It worked yesterday, as things do. So something very cool. So ChatGPT, AI, everything's coming out. One of the cool things here is I have Copilot enabled. So Copilot is built by OpenAI. It's the same folks who build ChatGPT. And it allows you to basically, when you install in Visual Studio Code the Copilot extension, it allows you to do cool things. It actually helps you write your code. So let me give you an example of that. So I was racking my brain. What's going on here in terms of why won't this Maven thing work? So what was happening is when it did the run Maven clean install, it was just basically telling me the run command wasn't supported. And I was like, the run command is a basic Docker file command, and Maven wouldn't run either. And I was thinking, is it my local Maven? What's going on? It wasn't any of that. So I had, let's comment this out to the way it was. And let's see if Copilot cooperates today, which it doesn't always. So I had this sitting here, and then I was just like, well, what if I just type from Maven? And look what it did. It actually auto-completed a newer OpenJDK 11 build, And I just said, okay, what the heck? Let's just try this. Let's comment this out and see if this works. So I just commented this one out, and it actually ran and it worked. Maven worked, the build worked, the run command worked, everything was fine. So that was kind of cool. That's Copilot. I mean, it's crazy how well it works. And it just solved my problem based on what other people did. So obviously what it does is actually notes the line that you're on, and it figures out from that line what else should be included in your code. So for example, let's go back. I'm going to check on the Kubernetes thing and see. It's still in progress. Okay, cool. So while we're there, I'll show you a little Copilot demo. So let's do a new file. And let's say a new Java class. Okay. And let's say a public class area of a circle. Maybe if I could spell right. Circle. Let's see. Come on. It usually does this. No, I just can't spell right. Nope, it's not doing it today. Oh, there we go. Wait a minute. It's going to fill it in. Hi. Okay. There you go. So it automatically will tell you code that you need for an area of a circle. Let's see. If you're doing I love this one. One of the standard textbooks questions you get in a job interview is, reverse a binary tree. So what if you just say public binary tree? There we go. So it actually helps you reverse a binary tree. Now, of course, the code is not complete. You need to have a way to return it and get a result and stuff like that. But it's kind of cool the way it automatically just adds code for you based on what other folks have done. So it's pretty clever, and it can really help you. In the case of my Docker file over here, it really helped me. And by the way, if you notice here, well, it is a Java file, but it automatically figures out that I'm using Java and adapts to that, which is kind of cool. So in this case, it actually saved me a ton of time. I was racking my brain. I spent about 20 minutes looking for the solution to my problem when using this build. And it just gave me a different version of the image, and everything worked fine, and I could carry on with my demo, which is pretty cool. All right, so that's a little bit about Copilot. Let's go into the code. Okay, deployment is complete. So we can go to our resource now, and we can see that the resource itself is here. It's running, and it's working. Nothing's set up though. I mean, the code is deployed, but we don't have that feature flag connection string in the code, right? All we did was build the repo, and inside of that build, we didn't pass the connection string to the Kubernetes destination. So the next thing we need to do is set up that in Kubernetes. So let's go back here. I should ask, hey Keto, have there been any questions? I haven't seen anything pop up, so I've been a little remiss in monitoring things, but doesn't look like it. Okay, so if anyone does have any questions so far, let me know. I'm keeping this casual, so
yeah, there's no questions yet, Brian.
Okay, cool. All right. So basically, what we've done at this point is we've created our container registry. We've created our Kubernetes. And now we need to securely add that connection string to the application itself. So the way you do that, oh, by the way, I can use the Azure CLI to create this as well. Here's the command to do that, but I didn't want to do it. I just wanted to show you how to do all that manually. It's just more For me, it's easier to see all the parts on the screen, and hopefully it is for you as well, rather than just running a command that tells you when it's done. All right. So the next thing we want to do is we want to install Coop control. And this is, once again, the Azure CLI. What it's going to do is it's going to set up Coop control on my local machine, and then we're going to actually get some credentials, and we're going to connect to the Kubernetes cluster that we just created. So let's go ahead and do that. Install the CLI. It's already pre-authenticated because we set up the admin user for the container registry. And for AKS, we're going to get the credentials right now. So that admin user automatically adds me and my credentials into the container registry, which is important. And no one else can access that. If you try and go to the URL for that container registry, you won't be able to see it. It's private by default. And by the way, it's built based on a version of Docker Hub, and it's for Docker Hub itself, as most folks are familiar with if you're working with containers, they have, Docker itself has a private version of that as well that you can run locally. This is just kind of the same idea. So we've already set up the path for our local machine here, so I don't need to do that. So my local machine can find Coop control whenever it needs to. And the next thing we want to do is get the credentials, make sure we're into JChampionsConf. Okay, so what it says here is it's merged JChampionsConf as current context in the Coop config. Cool. So now I can get nodes. Let's get nodes. And this will just show me the nodes that we have available in our Kubernetes cluster. Make sure we should have one at least. Sometimes there's three. There's three. Okay, there we go. So basically it just creates three by default. It's just sitting there waiting. And the code is actually on there as well. But the code won't work yet. The code will actually fail for a couple of reasons. And I'll go into why in a second. All right. So next thing we want to do is we want to run this apply command. So Coop control apply means it takes a YAML file and it applies it to the cluster that we have in the current context, which in this case is JChampionsConf. We went and got when we set up the credentials, it automatically sets that up for you. So Coop control apply feature flag secret YAML. What is that? All right, so this is the secret sauce where you actually pass the feature flag or any kind of connection string that you have securely to Kubernetes. In this case, what we do, and I misspelled secret, but I'm not going to change it. So the feature flag secret is basically passing the local environment variable that I already set up with the connection string. So if I go back into the feature flag, let's put all this back together here. GitHub features, this connection string right here, I've created a local environment variable for that. And that's why everything works and runs so far, including the AZACR build. So the AZACR build uses that same credential connection string to actually build the application and put it on the container registry, and then pass that from the container registry to Kubernetes. But Kubernetes still doesn't have the actual environment variable for this thing to run. So to do that, we have a feature flag secret YAML, and you say app configuration connection string, and then you pass the environment variable from your local machine into Kubernetes, and it stays there until you redeploy this. And the command you use for that is Coop control apply feature flag secret YAML. So let's do that. So secret created, and it's misspelled, feature flag secret. All right, and that's fine. You can call it whatever you want, but basically the idea here is that the app configuration connection string, which the application is looking for, is now an environment variable in Kubernetes as well as on my local machine. So that's kind of handy. So the next thing we do is we have ingress control. When we set up AKS, we can go ahead and get the result of that. And we're going to need that for a reason. I'll show you this in a sec. There we go. So this is the URL, basically, that accesses our application. And what we need to do, there's another file here. Is this the one? Yeah, Spring Boot to Kubernetes. So Spring Boot to Kubernetes is basically, it's on my local GitHub repo again. All of these, by the way, are on my local GitHub repo. And what we're doing is we're creating them here, and then we apply. So we take our local file and apply it to Kubernetes out in the cluster based on the current context, which is our JChampions conf cluster in Kubernetes. All right. So what we do is we come down here to the name of the container is Spring Boot to Kubernetes, and the image that we have from sorry, this is from the, I should explain this. This is how you link the actual container registry. Okay, so in this case, JChampions. Okay, JChampions conf we want. That's the one that I did earlier, Spring Boot to Kubernetes. So you want to change that to JChampions conf. So it's pulling from the JChampions conf repo. The next thing we want to do is we want to go down here to the actual service. So this is the Kubernetes service now. That was for pulling the container from the registry. And in this case, we want to change this to the link that we just got from our command line. All right, everything else looks okay. It's on port 80, good. All right. So basically from here, we've got this pre-made link. This link is what they're going to use for ingress on the AKS service. So you need to tell Kubernetes where to get that. So where to get the container and what the URL should be for ingress. Those are two things you need to do. So make sure I save this because sometimes I forget. And then there's a command that you add. Kube control apply. Once again, it's going to take my local file and it's going to apply it to our Kubernetes cluster. Let's do that. Right, there we go. So then I should be able to, this should work. Sometimes it takes a minute. Let's hope it works. Let's see here. Yeah. There we go. Everything's in place. It's probably still deploying. So, oh, it's there. Okay. We got the white label error message, which is good. That's a good thing. So there's the application running in Kubernetes. That's cool. The application itself is controlled by these feature flags, as I mentioned before. So you can turn on and off different features with the feature flag. Yeah, that's about it. So we deployed from just a moment. So basically what we did is we took my local repo, we packaged it up, we created a container registry, we set up the container registry to receive a container. Then we used ACR build in the Azure CLI command to actually deploy this out to the container registry. And then we created a Kubernetes cluster from scratch. And from there, we automatically deployed the application, but it didn't work at that point. What we had to do is then set up the feature flag secret YAML file. And that feature flag secret allowed us to actually connect to the feature flag manager. You get an error if that doesn't work. And then the next thing we did is set up the Spring Boot to Kubernetes with the Ingress and the connection to the JChampions conf that we're going to have, so that everything worked. We set it up on port 80, and this is the end result. Okay, so we're not done yet, though. There's another thing. Now, the title of this is with GitHub Actions and feature flags, so we got to talk about GitHub Actions now. There's a couple of ways that you can do GitHub Actions. Let's see here. This is the repo that we're using. It's called DevOps for Java Shops Test Feature Flags Containers. And by the way, one of the other things, so I showed you how to securely set up a secret for Kubernetes locally. You put it on an environment variable. But when you're setting up GitHub Actions, the GitHub Actions themselves need a way to run in Windows. On Azure, they call them, not Windows, but on Azure, they call them hosted agents. On GitHub, because it's a separate company, they call them hosted runners. So these are basically containers that run. They're pulled off a VM. I showed you before the documentation for those. That's what I was showing you here. Where was that? Where the hosted agents is basically what was showing you. I don't see here. But anyway, hosted agents are, I can go back here actually. Dashboard. So hosted agents. Yeah. So these hosted agents are, there's hosted runners as well on GitHub. GitHub has very similar hosted runners to hosted agents. In fact, they use the same images in most cases. And when you're running a GitHub action, GitHub Actions actually run on, this is where it was. GitHub Actions actually run on these things on GitHub. So when you're running the GitHub action, it runs on something called a hosted runner, and it uses those images to do that. Now, you need to have those secrets as well. So if I go in here and I see my secrets, so you go into settings in your repo, go down to secrets and variables, and you have options for actions, code spaces, and depend upon. I'll talk about code spaces in a bit when I'm setting up something else. But for now, GitHub Actions, I've set up some secrets, and you'll probably recognize that one by now. App configuration connection string is the feature flag connection string. You actually add it manually here inside the application itself. And then you can do other things as well, like the feature flags password, the username, and the Coop config that you're using for this particular application. These are things that you need to use for running a connection to a Kubernetes cluster. In this case, it's something that I built as a test in 2022. We're going to build another one in a minute here and deploy that as well. So the idea here is, this is very key. So you set up your connection strings. Some of these will be set up automatically for you, but this one, for example, I needed to set up manually so that the build doesn't fail in Maven when you're actually running this. Okay. So the next thing we want to do, I can go into just the main page here. I can go into Actions, and I can say New Workflow. And it'll start a new GitHub action for me, Java with Maven. We don't want that. We want deploy to AKS. You can go in here and you say configure. And basically, it's going to need secrets in the repository, just like I just mentioned, a client ID, a tenant ID, a subscription ID. There's a lot of work to be done here. I don't like using this one. I'm going to show you a better way to do this, but this is available if you want to. This is the way to manually create your GitHub action, and it gives you a nice template for doing that. And it gives you instructions on what you do. And it uses the Ubuntu latest runner that I showed you there. It checks out the code. Basically, you log into your client and set up your subscription, and then you do the AZACR build that I showed you before. The AZACR build actually builds the application and deploys it from this hosted runner, not from your local machine this time. And then you log in with your Azure credentials. It gets your Kubernetes Coop config, just like we did with set credentials in the Azure CLI. And then it deploys based on a manifest. But as I mentioned, this is a lot of work. There's actually a slightly easier way to do this. So if I go into my Kubernetes service, make sure I got the right one there, one we just created, and I go down here to Deployment Center, this deprecated, we're going to do automatic deployments. This is cool because it creates an automatic deployment for you. And it's going to give a workflow name. Let's see here. Let's call it J Champions Conf. It knows that I'm registered with GitHub already. I've already set this up because I tested it yesterday, and I'm authorized. But sometimes you have to log in and authorize your credentials for GitHub, because what this is going to do is going to reach out to GitHub, connect to GitHub, and build a deployment for you automatically using the GitHub action. So repository source ID, we don't want to use all repositories. That would be chaos. I've got a few. What was it called? It's sorry, I can't remember the name. Like darn, my own repo. DevOps for Java shops, test feature flags, containers. That's the one. I've got too many here. Be nice if they were in alphabetical order, but they're not. There it is. Way down at the bottom. Great. And then we want just the main branch. And we pick an image. So in the build context, we're going to use the actual Docker file that we have on the local machine. The Azure Container Registry, we're going to use JChampions Conf. And then we're going to use the test feature flags image. There we go. So what this will do is it will create a new version of this every time it does a deployment. We do deployment details. Docker file is required. Oh, wait. Oops, I didn't do that part. Docker file. Well, it should really just default to Docker file, kids. But anyway. All right. Next, deployment details. All right. So you have deployment options here. You can do Helm charts, which is kind of cool. If you haven't worked with Helm, it's really, really handy. Or you can use Kubernetes manifest files. Let's see. I think we'll use that. We'll use it. We'll just create a new namespace. Next review. Oh, actually, let's do Helm charts then. Yeah, that's fine. Charts path. Do we have one? I don't. Right, we need that manifest file. Sorry. There we go. All right. So the manifest file itself is there. We can review this. Then we deploy. So the new namespace was created. It's federated credentials. And what it's going to do is it's going to build a GitHub action for you. And it's going to deploy, but it's going to fail. It's going to fail the first time. So if we go back into GitHub repo now, we'll see this new action. Bum, bum, bum. There we go. So it's deploying to just now 4 jobs. So it's going to deploy to AKS. It's using a hosted runner, as I mentioned before, and it's deploying, but it's going to fail. And I'll show you why in a second. So I've actually got some workflows here that I've set up before. You need this reference to the app configuration connection string for this to run. So it won't run without that. It's not something that gets set up automatically because it's not automatically generated as part of a regular deployment, but it is something you do in the real world. So we're going to so basically it creates a pull request and approve this. You can approve the pull request here. Yeah, it's okay. It's failing. I know. Let's see, merge pull request. Okay. Close with comment. That's fine. So we're going to do something else here because this won't work. So as I mentioned before, it's going to fail. So now if we go into our code, you can see this new workflow in here. Oh, you should be able to see the new workflow. Where is it? Oh, because I didn't handle the pull request. Duh. Pull requests. Okay. Oh, I just set up a pull request. What's going on? One closed. Maybe we want to open this one. Add workflow to deploy to AKS. What's going on now? Yeah, this is part of the fun of live. I know it's failing. Okay, but normally you can do a merge. I know it's failing. Okay, for some reason it won't let me merge that pull request. There's someone probably out there who knows the problem. I'm just missing it right now. Maybe it's early in the morning for me. Hey, you know what? There we go. Okay. Just looks like the UI is set up a little differently. It used to be, instead of that close button there would be a merge, but the merge was somewhere else. Okay. Change the UI a little bit there. All right. So now we go into workflows. We should see, there we go. Okay. So this is the one that was done 3 minutes ago. All right. And as you can see, there's nothing there. So let me just make sure I'm placing this in the right place. Should be right after that on, but let's look at the other one that worked. Yeah, right after name. So before on. All right. Champions Conf. Okay. And by the way, you can edit this here. I can hit an edit button to edit this here, but that's not what we want to do. We're going to do something a little bit cool. We're going to go to the main branch. Over here, I mentioned code spaces before. Everyone's familiar with, you copy this to your local clone. You can then do a clone to your local workspace and work with it. But what if you don't want to do that? What if you're doing a demo and you don't want to have it cluttering up your local machine? I can create a code space here. So code spaces, I mentioned hosted runners before for GitHub. That's where Actions run. Also, code spaces runs on a version of GitHub runners as well. Code spaces is basically what it's doing right now is it's creating a container on a hosted runner on GitHub, and it's setting up a version of Visual Studio Code that I can use with my code here. This is not giving me direct access to the repo. This is giving me access to the actual code, but in a container. So I still have to push. And it's telling me here, extension pack for Java is recommended. Do I want to install it? No, because this is a demo. But if I wanted to, I could install the Java pack so I can work with Java. We're just going to edit a workflow file here. And let me just add this before I forget. All right. So we're working on the code here. This is on a pulled clone. The clone itself is running in a hosted runner on GitHub, and you have all the extra stuff that you had before. So it does things like if I want to mess with that Docker file that I was showing you before, if I want to, I haven't updated this. The one you were looking at before was my local clone. So let's see if this works. Copilot should still work in here because I have Copilot as part of my sometimes it's a little wonky on here. Yeah, it's not going to work right now. But you do have type ahead, you have controls, and sometimes you have Copilot as well. It's just not working at the moment. But Copilot, everything is installed here on Visual Studio Code. Everything should be set up the way it is on my default configuration, which is pretty cool. And I can edit this from here. That's the main thing. So let's just not edit that Docker file. But let's do this. So we have to add this mvar to the workflow here for this to actually deploy. And I'll go through the deployment after I send it back up to my repo. So as I mentioned before, CodeSpaces creates a container. It creates a clone of your repo. It's not the repo. So I still, even though I'm changing this in GitHub, I still have to push back to my main repo. So push back to main repo for JChampions. All right, commit. It's going to tell me we don't have anything staged, but yeah, I can stage it and then commit it and then sync changes. Okay. I don't want to run git fetch, no. I can install the recommended extensions for Docker too, but I don't want to. So one of the cool things about CodeSpaces, while this is going, because it's going to take a second, is it can also, you can create a custom configuration that's associated with your repo called a dev container. It's a .dev container file. It's a JSON file. It can automatically be generated, or you can manually create one. And what it does is it just tells CodeSpaces what to use when it's working with this repo. That's great for security. It's great for convenience and other things as well. So basically, we've pushed to the repo now. Let's go back to the repo. And we should see a new action running. And this one should, okay, it failed. I'm not sure why it failed. Build and deploy failed. Why did build and deploy fail? All right. Now that I've created the reference to that mvar, it should have worked because the mvar, as I mentioned, is in there. Maybe I need to set up the connection string. You know what? There's a few things I'd have to tweak basically to make this work. I might have an old version of that connection string in that repo or something. But you know what I'm going to do? I'm going to leave it there. I'm going to, we're coming up on the hour here. So I showed you how to do it. I showed you how to create. So we, from scratch, basically, let me go back to this slide so you folks can see that. So from scratch, what we did is we created the container registry. We created the AKS cluster. We deployed to the container registry using the ACR build. And then we deployed to Kubernetes and set up that secure connection strings so that the application works. So we knew it would work. And then we went in to set up the workflow. So we went into the Kubernetes deployment center with automated deployments using the AKS tool. We created a pre-made action, and that action was then pushed out to our repo as a pull request. We merged the pull request. Then we set up the environment variable. Now, that environment variable for some reason didn't work. I think it's an old version of the connection string or something, but you get the idea. So from there, basically, you have a whole action ready to go, ready to be set up. You just have to tweak the settings a little bit to make it work, just like you would in the real world. And that's it. The details for this step by step are at devopsforjavashops.com. And thanks for joining today. And we can take some questions if there are any. Otherwise, we're right at the hour. So hopefully that's there. Oh, there we go. Do you use VS Code for daily coding? Yes and no. I use IntelliJ a lot for Java. I know what you meant for Java. I use IntelliJ a lot for Java, but for VS Code, for when you're working with things like I just showed you with code spaces and GitHub Actions, it's just so much easier to use for me to use the built-in features like Copilot and other things. And by the way, IntelliJ has a extension for Copilot as well. If you want to use it there, just search for the IntelliJ Copilot extension. And I believe there might be one for Eclipse as well, although I haven't seen it lately. So don't quote me on that, but I know for sure there's one for IntelliJ too. So if you want to use Copilot, I just find it very convenient to use it. And I work for Microsoft, so we get a lot of cool stuff and things like that we can use. But yeah, I use Visual Studio Code for demos like this. For IntelliJ, I use if I'm setting up a project, for example, if I'm working on an open source project where other people are working on it and they already have pre-configured settings in IntelliJ, then it's easier to use that. Hopefully that answers the question. Are there any other questions or?
I think that's it.
All right. Well, if anyone wants to reach out to me, BibEnz on Twitter, Mastodon as well. And yeah, please do reach out and keep in touch. And thanks. DevOps4JavaShops.com is where you can find step-by-step instructions for this. I've got a workshop that I've set up there as well. So
awesome.
Yeah.
Thanks so much, Brian. That was very cool.
Thank you. Thanks, Keto. And thanks for moderating. Appreciate it.
You're welcome. It was really hard work. Thanks everyone for coming to Jade Champions Conf, and just remember there are several other sessions today and also on Monday and Tuesday. So it's really easy to just drop in and out when you have time. So thanks for coming.
Thanks.
Bye.